Hey friend, and welcome back to the channel. Today we're going to discuss an end-to-end machine learning project, a classification problem. This is a churn project where we try to predict if the customer is going to leave the company or unsubscribe based on the features that we have. So the difference between this project and many of the projects that you'll see on the internet is that usually on the internet you work in notebooks and you just do a few nice models, you focus on accuracy or one metric, but you never deploy really in the real world and no one can really use it apart from you in your own computer. But today we're going to go through the whole process from raw data into deployment, where you can share with anyone this project and they can also go and input their numbers and get the predictions based on the model that you fine-tuned, that you worked on. So just to give you a very high level overview, the thing that we're going to cover, we're going to go from raw data. I'm going to show you from where we're going to download it. We're going to do data validation with a quality check tool. We're going to do pre-processing of the data or cleaning. We're going to do some feature engineering, model training. We're going to train a few different models. And then we're going to move into model packaging, which we're going to use Docker and CI/CD pipelines with GitHub Actions later on in the CI/CD automation. We're going to deploy to AWS, and we're going to do some basic monitoring within AWS to see how our model performs and if everything is doing well. So as you can see, this is quite comprehensive and it's quite different from what you see usually on the internet, very straightforward notebooks. This will be way more comprehensive, and therefore I won't be walking you through each and every part of the code, writing it from scratch. I'm going to show you what I've built module by module. You can have access to everything in GitHub, which I will show you in a second. You can clone the same repository and just do the same steps as me, and you should be able to reproduce all this by yourself. But obviously, if you're more interested in doing a deep dive and step by step, you can start the whole project from scratch and get inspiration from everything that I'm going to share with you. So first of all, you could go to this link in here, and I will link it in the description below. This is where the repository for this project lives, and you're going to see that we have everything within it. You're going to find a README file, and that one will give you more of an idea of what's the purpose, the problems we solved, what we built, and even some roadblocks that I faced while building this, because as you can imagine, it's not as straightforward as just watching a small tutorial and being able to reproduce everything in 1 hour. It took days of work, but I will try to package everything for you so you get more of a high-level idea of how data scientists and machine learning engineers work, and not just a very high-level tutorial, So you're going to find all in here. You just go in your VS Code. I'm going to show you, and you literally just take on the link. And if we go to VS Code, I'm going to just do a new terminal here at the bottom, and literally just do git clone, and you put in the link. And that's how you can clone all the projects in your new VS Code page, or if you use Cursor or any other IDE, it should be roughly the same. So that's the first thing. So let me walk you through the dataset. And this project is from Telco, and Telco is a telecom company basically, and we want to analyze if their customers are going to churn. Basically, are they going to leave the company for whatever reason? So this dataset has 7,000 customers, and it has roughly 20 features, which means columns. And what we want to predict is if they're going to churn or not, if they're going to leave or not, based on the features. We try to build a predictive model here. It's a classification model, a yes or no, based on the features. In a project like this, it's very important to identify what is the metric, the KPI that matters the most for the business. So when we think of classification, we have a few key metrics that we look into. There is the accuracy, there is the precision, there is the recall, there is the F1 score. So you need to understand which ones matter the most for your business. And in our case here, the thing that will harm the business the most is people leaving the business, the company. They unsubscribe or they just cancel their subscription. And that's the best metric for it, is the recall. So that's something very important to understand. So first of all, we can go into Kaggle in here. I will, of course, share the link in the description below, so you can just go and click it. And you go at the bottom here, and you have this button here to download. You just go, click on it, and it will download the CSV file for you. And you just go and put it inside of your project so that you're able to work with it. So if you go to my GitHub, you see that the data is not in here. This is just for me to not put too many things and make super heavy GitHub. I just keep it locally, but you can do it. The data itself is not that big. You just download it and go and put it inside the folder. So if we go and look into briefly our code, let me just close here everything. Just want to show you briefly the structure that was used in our project here. So you see that if you do git clone, you're going to be able to bring all these things in here, and the data will live in a folder like this, data. So you have the raw data, which is the one that will be downloaded from the Kaggle that I showed you. And then when we have a few other steps, like we're going to process this and everything, we're going to just include it in here. So this is where you're going to put your data set inside of the folder data, and inside of it, inside of row, that's where we're going to put it. And the rest, obviously, of the code, we're going to walk through it. But this is one of the structures that I use. And this one is just to have a nice structure of what's going to happen step by step. So I know where I have my notebooks. I know where I have all my Python scripts. I know what I have, for example, just some README to go and read and add some details about what's going on, so on and so forth. So for now, we're going to take things step by step. If I go back in here, I can briefly walk you through the tools that we're going to use so that you have more of an idea what you're going to learn today and what you're going to play with today. So first, we're using Python to do this project. In my case, I use VS Code is the IDE that I use. You can use Cursor or you can use PyCharm, depends on your preference. It shouldn't matter. We're going to use Great Expectations, and this is just a Python library that is going to help us basically just do a quality check of our data. So when we receive a new stream of data, it needs to fit some business requirements, and that's something that a lot of people completely neglect in their tutorials. We're going to do it. I'm going to show you how we implement it. Remember, this will be a high-level video in terms of coding. I won't be coding live. I'm going to be explaining to you what's in there because it's a heavy project overall. We're going to do some modeling, and the machine learning model we chose is the XGBoost classifier. I've tried a few. I'll show you briefly, but that's the one that gave us the best performance overall. We're going to use Docker for building a container for our project. So what happens in most tutorials is you get people that do a project in their own machines and everything works. They have the libraries, everything installed, the Python version, and then when they try and share with other people, it completely breaks. And that's because there's a mismatch in the dependencies, libraries, and the setup. And Docker removes all this headache. When you take your setup of the project and everything within it and put it into a container, then anyone from anywhere, like yourself, you could literally take this and reproduce it without having any issues. So we're going to walk through that as well. We're going to do and use MLFlow. And this is for tracking the experiments that we do in machine learning. So all the metrics, artifacts, everything will be stored for us. So for example, let's say you work within a team and you try 10 different machine learning models, or you try to fine tune a few things, and you want to roll back to the one that worked the best 3 months ago. This is how you do it. You will find all the historical of it. We're going to use FastAPI to have an HTTPS endpoint, which means that our model will be exposed to the internet so that it's usable from the internet. And that's a very important step what we're going to deploy, because when you go to the cloud, you will need a way to be able to communicate with your model. And if it's not exposed to the internet, you can't work with it. So that's a very critical one. We're going to use FastAPI, which is the one used in production in most companies. And we're going to use AWS. It's one of the most famous clouds. We're going to use AWS ECS, which is the Elastic Container Service, if I remember. And this one, we're going to use a serverless solution, which is called Fargate. And lastly, we're going to create a UI, a web UI with radio in Python, just so that any user is able to plug in some numbers and get the machine learning model to work for them. So for me to give you a demonstration of what it will look in the end, here I created this UI with radio, and this is exactly all the features that we have. And when it's deployed, if I just go and play around with all the values that we have in here, and then I just plug in and click on submit, we get the prediction not likely to churn or likely to churn. So this is like in real time, we're using the machine learning that we built model, and we're getting the output required. Obviously, in reality, you'll have a stream of data that comes every day, and this output will be generated automatically. But since we don't have that stream of data, we're working with the static data that we have, but we're going to do exactly the same steps as you would do in production. So let's take things a step at a time. And just so I remember, when you go here and you want to clone the repository, you can take the link in here. You can give this repository a star as well to support me and to support this kind of content, because I will be doing more of it and it doesn't cost you anything. And then when you go on your VS Code, you just do, as we did earlier, you just do git clone and you put in the URL, and that's all. You should be able to clone it. But for those that want to start a project from scratch, I'll briefly show you the way I do it in a quick way. I just save some commands that help me start a project from scratch and create all my the folder, the project structure, the environment, the requirements, and the libraries within just a few commands that I will show you right now. But this is not necessary if you clone the repository. It is not necessary. This is only necessary for your next project when you start it from scratch. You can use these commands for yourself. So what you would do, you'd create an empty folder, for example, on your desktop. You're gonna put it into VS Code, like literally drag and drop to start a new session. Then you're just gonna go to terminal. You're gonna type this. It will create the whole structure for you. And then let me do a demonstration for you so you get an idea. So let's say I go and I create a folder, tests. So I'll come to VS Code. I'll start a new project. Let's say I do here. I'll just drag and drop a new empty folder. So to create a new session for me, I just called it here tests. Let me zoom in here. I'll close this. I'll just go to the terminal at the bottom, and I will literally just copy paste the command that I showed you on my Notion. So it's this one, and I'll just press enter, and you see all the project structure was created for me within seconds. No need to create manually. Then we can go back here and look into what's next. So after the project structure, I will just include a quick README. You can also do it programmatically from the command line as well, or you can just go and inside your project, just create readme.md, and here you type anything about the project. This is just showing you if you're doing it from scratch. I won't spend too much time in here. Then we're gonna go and add requirements.txt, which is the one that will have all the libraries that you want to install. You can add them just by using this command that I did in here. Let me just run it here for you at the bottom. So we just did it here, and it will create, as you can see here, our requirements.txt for us. You can add any libraries that you want. And in here, we're going to create our Python environment. And this is very important. We have here, we specify which Python version we want, with the name of the environment, and we're going to activate it and install all the dependencies. So if we do that, you can do it one at a time, but if you do that, you're going to end up creating a new environment, and you're going to activate the environment, and you're going to be creating and installing all your libraries in there. As you can see, we've installed all of them, and now we are inside the virtual environment. So this is just tips that I'm sharing with you here in case you want to be reproducing yourself and starting new projects. That's how I start them. But now we're going to jump into the project itself. So now that I showed you how to set up the environment and do everything, especially if you're doing the project from scratch, we're going to jump into the exploratory data analysis. And this is where you do most of the things that you would like to then modularize and deploy in the cloud and everything. So this is the phase where a lot of data scientists that are good at modeling, or data analysts that are good at visualizing, exploring, cleaning, they shine in, and myself as well. So what I do usually is that I would do the whole project, or most of it anyway, I will do it inside a notebook. And the reason why is because I can explore easier. I can open the data in here. I can clean it. I can get a better idea of what's going on. And then afterwards, I will think, okay, how can I make this production ready? And I will try and split each and every task done. You know, loading the data, cleaning the data, building the features, and all that kind of stuff. So here I included a basic about the data. So we just talk about what we do with this data, what is the content and things like this, which is not, we already spoke about it. So what's interesting is to look into the data. So we here imported the libraries that needed, pandas to work with tables, SNS and matplotlib here, Seaborn and matplotlib to visualize basically. So we just bring the data, we just bring it into a data frame, and then we read it, just one row. And here the goal was to just look at what, let me run it all. Here the goal was just to basically look at what the data looks like and what are the features that we have. So here we can see the data, the features that it has, we can see all the columns, and here in the end we can see the column churn. So initially before the processing, the column churn will have either a yes or no. And after doing the processing, we're going to turn things and encode things into numerical values, because in machine learning, you will need to have your features, which are the columns that we have, numerical, so that they can be read and processed by the machine learning model, because it only understands numerical values and not categorical values that has letters in them and characters basically. So yeah, we're looking at this data set, and then we're gonna just basically try and explore it, try to see if there are not missing rows, for example, if there are any outliers, weird averages. That's like an exploration phase, I will call it. But basically here, it's clear for us that the target is churn, and the other features are the ones that we're going to use to try and predict the target. If it's yes or no churn, we're going to use all the other features that we have there. And we can already see the payment method, how many they charge per month, how much they already spent, and all this kind of stuff. The contracts, what do they have, online security, the tenure, how long, etc. So we're gonna look deeper into this. I'm gonna skip this part. And what we're gonna notice is, when you look at the data, is that we have some of the columns or the features that have two different values. For example, gender, here we have male or female. Dependence, we have yes or no. Multiple lines, we have 3 options. And most of them have 3 options. And the churn one has, the payment method has 4, and churn has only 2. So in a classification model where we have a few categories, there are different ways of approaching things. If it's a binary classification, it's a yes or no. It's usually very straightforward. We can turn them into 0 and 1. Nothing difficult about it. But if it's more than 2, there is the possibility of choosing another type of encoding that we're going to use. This is a multi-class encoding, and in this one, using a one-hot encoding is the best option, because we have more than 2 features, but we don't have too many either. So if we had more than 10 or something like this, we will need to look into something completely different again, because one-hot encoding will end up creating more columns. It's like binary. Think of it as binary. If you have 3 categories, it will give them a numerical value of 001 or 010. So it will like create for each and every category a separate column. So you can imagine if you had 100 and you have 100 times that you need to do those binary new columns, you'll have just too many columns to deal with, which will make it very complex for the computation. So that's something to keep in mind. So when you do the encoding, if it's a binary encoding, you just do 0 and 1 like we did here. Yes or no will be 0, 1. Male, female will be 0 and 1. And you'll just literally just turn those into zeros and ones. And that will help us for our machine learning model to just have the numerical values instead of textual and characters. And for those that have above 2, which means they have 3, 4, 5 categories, we used one-hot encoding with this function here, .get_dummies. And what it will create, as you can see, will create more and more columns for us that have Boolean values, false, true, false, true. And that's why I'm telling you, if you had more than 10 categories, for example, it will become so big and so difficult to deal with. Then obviously we'll need a cleaning phase, and this one is for anything that was unusual that needs to be cleaned. And in our case, we're going to drop the customer ID column because it's kind of irrelevant to predict the churn. We could have removed the others, but that one seemed to me from the start that it's completely irrelevant, so just remove it. We're going to turn all the columns that were Boolean because all these that had true false are Boolean. So we're going to turn them into 0 and 1. So false 0 and true 1. It's as simple as that. So that's all our columns that we're going to use are numerical, either integers or floats. That's very important. And then we're going to move into looking at the correlation. We're going to create a heat map to see the correlation to the churn. And let me zoom in a little bit more. And we're going to see here we have the positive correlation up until the negative correlation. So we can see here the positive correlation. We can see that there are two that kind of stood out. The fiber optic option for the internet, they correlate a lot with churn. For some reason, people in this data set anyway, people that have fiber optic are more likely to churn. And those that have a payment method of electronic check also are 30% likely to churn. And on the other hand, those that have contracts of 2 years, which is like long contract, or they stayed long with the company, are less likely to churn. And I added a few notes in here just saying that negative correlation or positive correlation, both are quite important, because sometimes a high negative correlation says that when this is high, we are less likely to churn. So that's also something to optimize for. It's very important to know, because if we had a set of 1,000 categories or 100, we'd want to only keep the ones that are relevant and not compute for 100, which are unnecessary. We look into this multi-collinearity in the classification problems when we suspect that some of the categories or the features that we have might be multi-collinear, which means that both of them basically give us the same information, which makes the model very redundant. And when we do this VIF, we look at this, and if the number is above 6, 7, 8, 10 maybe, there is a multicollinearity. And we can see all these features here have a very high multicollinearity. So there are a few options here to consider. We either drop some features, or we can do some regularization techniques, like there's L1 and L2, ridge and lasso to use. We can see them in here. I added notes. Or use a tree-based model, something like the decision tree or the XGBoost or the light GBM, because usually they handle these scenarios really well. And in my case, that's what I did. I jumped into a tree-based model so that we can completely not focus too much on this and start modeling already. So here in modeling, we can see first that I'm looking at the column of churn, and what I easily notice here is that there is a class imbalance. We have 5,000 not churning and only 1,800 churning. So there is an imbalance, and in your data set, you have to do everything possible to get a data as balanced as possible, because if you don't balance it well, then what's going to happen is that your model will start predicting more of the value that appears the most, which is fair enough. And in our case, we'll just need to make sure that we make it more fair, and there is a way of doing it. We can just adjust a threshold. So when we do the model, when we adjust the threshold, we can adjust the how much one category is compared to the other. So that's one of the ways that you can do it. Obviously, there are other ways of you can resample and things like this, or maybe duplicate some of the churned ones to get a more balanced data set. But that takes time, and there is a lot of also validation that needs to be done there, and it needs to make sense. Otherwise, you'll just end up messing with your data. So we're going to use this threshold. So one thing that we need to focus on and talk about is what is the metric that we're going to work with. And the metric that we want to focus on as a business, so if I was in a telco company and I need to build this machine learning model, what is my main thing? What is the thing that I'm focused on is not losing clients, which means that we don't want the false negatives. And the false negatives, the one that focuses on it the most and try to optimize, is the recall. So here, if we look, business context prediction is asymmetric in cost. So false negatives, you predict a customer will not churn, but they actually leave. You miss the chance to intervene and keep them. And this is the worst thing that we want to be able to avoid. We want to spot all the people that were going to churn and maybe give them an offer, give them a discount, make them stay. And this is what we're going to focus on in our project, is optimizing for recall. And obviously there are trade-offs when you focus on recall. you end up losing precision. So that's something that needs to be discussed with stakeholders, and it's very important to keep that in mind. Because you're not building just for the notebook, you're building to benefit the business. And you don't want to harm the business with your model. So as I mentioned earlier, I've tested the random forest classifier. I've also tested the LightGBM classifier. And lastly, I tested the XGBoost. I don't want to walk through each one of them. That's not the purpose of the video. I ended up choosing the XGBoost. It was slightly better performance than LightGBM in terms of recall. And it was faster. So faster is something to consider when you're in production. You want to have things to work fast and with less compute. XGBoost doesn't mean less compute. It just means in this case it was faster, and that's why I went for it. So we can see here it ran the training time in 1 second, and the prediction time was like in no time, literally. Here we can see precision, recall, F1 score, and support. So it's very important to know that accuracy is not the only metric in classification, and accuracy, it's in many cases, is just when the data is super balanced and when we don't really care about the precision or the recall that much, in terms of none of them really affects too much our client base or our results. In our case, we want to optimize when recall equals to 1, which means that we want to spot all the people that we're gonna leave the company, that we're gonna churn. And this is the metric that we want to spot. So we have here 81.8% that we're able to spot with our model. So here what we did next is that we tried to look, because we used the threshold 0.3, and this one is to try and unbalance the data. And here what I did is I just tested a few different thresholds just to see what is the recall, because that's what matters to me the most, based on what's the threshold. So here with different thresholds, 0.25, 0.3, we get different recalls, and also we can see precisions and F1 score, which is kind of a mix of both of them, which is a very important one when you want more of a balanced response. So here I can see that if I go for 0.25, I get a better recall, but the precision drops a lot. So I might just leave it like this. But this is obviously a business decision to discuss with the stakeholders. But in our case, I am the person making the choices. So let's say I'll keep it 0.3. So I chose the XGBoost. It gives us a decent recall, and it's faster to train. So that's great. One step that a lot of people kind of neglect as well is fine-tuning our hyperparameters. So XGBoost has all these parameters in it. And by choosing and finding the right parameters, we can very much enhance our model. And what we do here is we use a library called Optuna. It's a great one. And we can just give it like a range of things to experiment with. So for example, the estimator from 300 to 800, the learning rate from 0.01 to 0.2, and so on. For all this, it will try a variation of things, and then it will give us the one that gave the best results. So if we keep going in here, we can see we're gonna optimize, and we're gonna do 30 trials. So it's basically gonna try 30 times, and it gives us the best one of them. And you can see here, if we take just the trial 0, we can see it gives us here the recall. It gives us what are the hyperparameters that was used for that exactly. And in the end, if we go down, it will give us here best parameter. Let me zoom in a little bit more. Best parameter, and it gives us, it was this one, 300 estimators, this learning rate, this max depth, this, all of them basically. I don't want to walk you through all of them. And that one gives us the best result. And then what we're going to do is that we're going to just bring those best parameters, instead of writing them ourselves manually, we're going to just bring this one, best parameter, and we're going to just do a random state of 42 so that when we rerun, we get the same thing. And then we're just going to time it to see how long it took and everything. So basically the same as we did before. And here we see that we improved to 92.8%, looking at the recall equals to 1, meaning that the possibility of the client leaving the company, which is very important. Yes, we get a lower precision, but in our case, we said we're going to optimize for recall. And we see that we optimized from 81.8% to 92.8%. So it's 11.1% of people that were going to churn that we kind of saved with this model. Yes, we're going to target more people that weren't going to churn with our new campaigns, but you'd rather save those that were really going than, you know, just sending a few more emails to people that were going to stay in. So this tuned model here gave us 92.8% of recall. So it's the best. The precision is very low. So many loyal customers are being flagged, which means that we're going to end up contacting them thinking that they're going to leave, but they won't. And this is the, in the classification metrics trade-off, where you have an increase in recall, but a drop in precision. And you always need to find that balance where it's acceptable. And in our case, we aimed for a high recall and we got a high recall for now. So now if we just wrap this notebook, and you can see what all we did, we explored the data, we loaded the data, we explored it, we did binary encoding for the categories that had 2 categories in them, and we did one hot encoding for those that had 3 or 4 categories in them, like values. And then what we did is we cleaned the data, we turned the Boolean columns into numerical columns, we dropped some columns, then we looked at the multicollinearity, but we found out a few features were highly multicollineated, and we decided to use a decision tree based or a tree based model like XGBoost. We tried a few machine learning models like Random Forest, LightGBM, XGBoost, and we decided to go for XGBoost. And then we fine-tuned the hyperparameter to boost our results. The experimentation here with MLFlow, I left it for the next phase, and I'm going to show you how we're going to do it. So usually, if you did everything in here, this looks a lot like the tutorials that you usually follow, and then you stop. And you're like, I've built a great model, I've got a great recall, I'm great. But no one can use this model. And therefore, that's why the importance of going through the pipeline, of going next to modularize everything we've done into Python scripts, and then adding MLFlow for tracking machine learning models. Then we're going to use FastAPI to serve that model into the web. And then we're going to put that all into a container so that it's reproducible from anywhere. Then we're going to use GitHub Actions so that we're able to test, run, and push that container into the cloud. And in the end, use AWS so that we're able to deploy and also visualize with our Gradio UI and share it with anyone from the internet. So we're going to keep going step by step. The next phases will be less code-oriented, less technical. I will still go through them, but not in a very detailed way as we did now with the notebook, because with the notebook, you got the idea of all the steps. Now I'm going to show you how we split them and focus on the important modules as well. So let's do a quick recap of what we did initially. We just went through the environment setup, the library installation, the GitHub repository, I showed you how to do it from scratch. You also need to go to GitHub and create your own repository. And I also showed you how to just clone it and bring the same project as I have in your environment. Then we walked through the exploration. And here we went through the problem, the data, we analyzed it, we built the model, we did hyperparameter tuning. And our conclusion is the model that we chose with those hyperparameters. And here, what we did, we focused on the recall, which is the business metric that we focused on. So I left all this information here. I didn't have to read too much through it because we built, and that's the best way to do things. The next phase will be to turn the notebook, everything we did, into Python scripts. And why do we do that? This is very important. We do that because first, it's nicely split, so we can modularize each part of the notebook in a different Python script. And that is because we can easily troubleshoot or test each and every part of it. We can, for example, load the data and we can test that. We can process the data and we can test that. We can build the features and test that without having to have everything in one, and we don't know what broke and we don't know how to change things. And it makes it easier for our pipeline to be nicely organized and call each and every one of the scripts when needed. So this is a very important step, and a lot of people, when they go from notebooks into Python scripts, they get lost because you don't have the same interactivity of the notebooks when you write Python scripts. Anyway, so this phase is very important, and we're going to walk through it very slowly. So if you just think of what we did in the notebook, it already gives us a hint on the step-by-step that we need to take. So for example, we initially loaded the raw data. Let me see if we can zoom in here a little bit. We initially loaded the raw data, basically the CSV that we loaded it. We're going to have a script for that. We're going to run data quality checks, which I'm going to show you now. There is a library called Great Expectations. Then we pre-processed the data, we cleaned and we did some transformation. We did some feature engineering, and basically this is the encoding that we did for the binary and the multi-classification and multi-class basically encoding with one hot encoding. And we handled categorical numerical transformation. So basically that's what we did in here. Then we trained the model. We're gonna train machine learning models. We're gonna do hyperparameter tuning. And then we're gonna do some evaluation, basically. Evaluation, that will be with testing, and we're gonna also use MLFlow so that we keep tracks of the machine learning experimentations that we did. We create, and I will show you, a random underscore pipeline.py, and that one will basically have all these modules. We're going to be able to call them in one so that we're able to run the scripts. And we're going to have the experiment tracking with MLFlow, which will log some of the important metrics that we want from the model, like the accuracy, the recall. You've got to save the hyperparameters and everything. And here I didn't include the recall, but it's the metric that we focused on here, basically. So let me here show you just a simple flow. If we just look in here, we can see we have loading the data, we have quality check, pre-processing, we have the encoding that we did, so it's the features that we've built. The model we're going to train, tune, and evaluate. And here we're going to do some testing. It's basically just unit tests, just to make sure that everything runs well. We have a run underscore pipeline, which basically will orchestrate all the training. We'll do everything that we've done in the previous scripts and will run them for us. And the results of those machine learning models, the recall, the accuracy, everything that we get, is going to be saved in MLFlow. And then we can go and track and use whatever machine learning model that we want to go to the next phase, which will be to more containerize and productize and deploy everything that we've built. But this phase is very necessary, and it's one that a lot of people skip. So in here, in our environment, if I zoom in a bit more, we can see that we have this, let me close this, save. We have this SRC here, and this SRC is where I'm gonna put all my Python scripts that I need. We have the data, which will have our initial phases of loading and pre-processing. We have the feature, where we have the building the features part, which will cover more into all the encoding. The models, everything that is touching the model, which is training, tuning, and evaluate. We have the serving part, which we're going to have the inference.py, which I'm going to show you things step by step. And here, important one, is validating the data with Great Expectations, the library that I told you, where we can check the data. And this one will be a step just after loading the data. We want to check the quality of it before going to the next step. So we're going to walk through each and every one of the Python files in a very brief way, but I'm going to still explain things. So we're going to go first to the load data. And this one is very simple, straightforward. We're basically loading the data. We're given the file, the name of the file or the path of that file. And then we're just going to return pd.read underscore CSV, the file path. This is what we do basically, even in a notebook. We just do import pandas as pd, and then we just read with pd.read underscore CSV. Then we're going to pre-process the data, and this one is just the cleaning step that we did initially. So let me do this. If we look at this, I've added some comments, so it makes it easy. We just trimmed some column names. We dropped obvious ID columns, so we removed the customer ID column. We fixed the total charges to numerical, and we just did some mapping in here, and we handled simple NA values, which means that they didn't have any value in them. So you're gonna see each and every one of these ones is what was mentioned at the top. So for example here, total charges often has blanks in this data set. We just want to turn that into float so that we don't run into a lot of errors when doing the machine learning model. Here citizens should be 0 or 1. We just made sure that if it was missing, we just put 0 by default, because that was the one that appeared the most. Obviously here can be optimized as well, but we don't want to spend too much time in each and every one of the things. There's always something to optimize. And here is just the simple NA strategy to fill in with 0 things that are missing, basically, in our case in here. So this pre-processing call, it's also cleaning, and it's a very important step, and it lives inside of SRC and inside of the folder data. The next one will be the features. And in the features, we're going to build the features. We're going to have 2 functions. One is for the binary category, like churn, for example, yes and no, male and female. And this one is when the length of the categories, how many we have basically, is equal to 2. And any feature that has only 2 categories is going to have this 0 or 1 mapped into it. So if we know the name of the features, then we just specifically mention which ones they are. And if we don't know, maybe a few other features will appear over time, then we just do, in general, generic binary mapping in here. And in the second one, this build features, this one will focus more on if the features have more than 2 categories. We can see here explicitly, if they have more than 2 categories, then we're gonna do a one-hot encoding, basically. We're gonna use the df underscore get dummies, or pd dot get underscore dummies in here, so that we turn multi category columns into all those multi-columns that are Boolean for each and every one of those. So this basically has two main functions. They might seem a little bit complex because we try to handle a lot of things in here, and I don't want to dive too much into the code and how to write these functions. You can go play around with them. You can use ChatGPT or something on the side to explain to you if you want to deeply understand how each and everything is done. And I've added some descriptions here for you that might help you understand things a little bit better. But before going to modeling, I forgot I needed to mention the validation of the data. So this goes after the step of loading the data. We're gonna validate it. And this is important because we want to make sure that the data that will come in afterwards is qualitative. For example, if we have male and female, and then we end up having something that comes and it's not within these two, this is an error we don't want to bring into our data because it will break everything afterwards. So from the start, we're going to go through each and every one of the features. We're going to check that that column exists in the first place. If it doesn't, okay, throw an error so that we know that there is something new coming. And then for each and every one of these columns, we want to set what we expect to receive. For example, for gender, we expect it male or female. Partner, yes or no. And we're going to do that for each and every one of the columns. And for those that have a numerical value, for example, a tenure, we want to look that the minimum value is 0. We don't want to have one that has minus 15. It needs to throw an error because otherwise it will end up affecting all of our data. And the maximum value, for example, is 120. People that were there for 10 years, because you know maybe in your data there's no one that has been there for 10 years, or the company is maybe just 10 years old. So it's impossible to have someone that is over 120. So this is just like a set of boundaries that you set for the new stream of data when it comes, so that it doesn't break everything that you've done. So that's very important. And you're gonna see it's done for each and every one of the columns. That's why the code seems to be big, but it's just for each and every feature that we have, and we have over 20 features. So that's why it might seem a bit long, but it's just a quality check. And all of this is done in a function called validate telco data. We're basically just validating the data. Now we jump back into modeling, and we're going to look into training the data. And in training the data here, we can see that we have MLFlow, we have our model XGBoost, and we have scikit-learn so that we can train, test, split, check for the recall, the accuracy. In our case, we're looking for the recall primarily. And here we create a function train model. So basically, this is what we did in our notebook. It's just that we're now turning them into functions that are reusable. And in our case here, we just X is for the target churn, Y is the other columns, and just we do 20% for tests. We put in here the hyperparameters, and then here, what's interesting here is MLFlow. So MLFlow, what it does, it basically tracks the machine learning experiments that you're doing. So every time you run your model, you will have this folder here, ML runs, that will keep a record of that model that was run. Let's say this one was the one that was run the latest. We see that we have artifacts. It saves the model into this model.pkl. it saves the metadata, it saves the metrics, so we can see the recall. Look at the recall here, 0.82, and it saves the precision, it saves the parameters, everything. And this is fantastic when you want to go back and look into a specific model that you want to maybe revert back to because it performed well or anything like that. So let's look into it. We have this MLFlow. We start run MLFlow. That's how you start it basically. And here, everything that we want to log or keep, we're just going to use this log parameter, log metric, and here log metric recall, accuracy, and estimators, and we want to log the model itself. And this is very important because this is exactly what's going to show in the ML runs in here, and that's exactly what you're going to find. The artifacts, the metrics, and everything. This is a very important step. And then in the end, we just want to print the model trained, the accuracy, the recall, whatever is the metric that you focused on. So when we train, we want to afterwards tune. And we saw that we used Optuna. Optuna is the library that we use. And basically, instead of me again going through it, because we did it in the EDA, that's why it was important to go through each and everything step by step in the EDA, because here we're literally just taking the logic of those things and just splitting them into scripts so that it's modularized. It's called Modularise in Python scripts. So we go Optuna, and we're going to basically just tune the model. And we get here say that we're going to use Optuna to fine-tune XGBoost. We're going to again set this like boundaries that we're going to try in. And then we're just going to expect Optuna to give us the best parameters based on a number of 20 trials. We can do 50, but this will be more computation. You can do 100. That's completely up to you. And then we can just evaluate the model, basically just getting the classification report and everything as we did earlier to see the trade-off of recall, precision, and all that kind of stuff. We've done it here as well. Here, if we look on the left, we have the SRC, the one that had all our Python scripts, but we also have this script part. And here, this one is very interesting because we have a few Python scripts that help us test the pipeline. For example, when I wanted just to test the phase 1 where we did build the features, or the phase 2 where we did the modeling, it's just a quick way to test our Python scripts. Or here, for example, if you want to run the pipeline. And this one here is interesting because this is the one that will englobe everything that we've done in those Python scripts. You can see here, load, validate, pre-process, and feature engineering, and the modeling and the hyperparameter tuning will be done in here. So the way you do it, basically, we call all the libraries that we need. And then we're going to just go and call each and every script by doing this. So if we go back, we can see, for example, here, if we want to load the data, we're going to need to go to src.data.load_data. That's what we did here exactly. And that's how we import load.data, load_data.py. And then we do the same for pre-process. If we want to get the pre-process, we do it from the same. And if we want to get the features, you basically just go and track where it came from, the path, and you just call it. And this is very important, otherwise it won't work, it will break, and you will have to figure that out. Something that used to happen to me all the time and still does, and you just get used to figuring these things out. And basically what we're gonna do afterwards is that we're gonna create the machine learning model in here. We're gonna do the data quality validation, we're gonna do the data pre-processing, we're gonna be calling our functions that are already inside the Python script. And basically it's just like bringing all those scripts in one and running them so that we do the loading, we do the pre-processing, we do the quality check before the pre-processing, then the pre-processing, that we handle the class imbalance, that we're gonna run our XGB classifier, we're gonna bring in a few hyperparameters, and everything all done in one script. This is a very heavy one, but think of it as just regrouping everything that we've done in the Python script so that we're able to run the pipeline from here directly. You just run your pipeline, and then you're gonna have a new entry in your ML runs based on whatever you've put in here, and you can change it as needed, and you're gonna get again another new ML model that is saved with MLFlow. And that's the beauty of MLFlow, is that everything is tracked, and as you can see, I've already done a few runs and each one of them was saved. So then I just need to go back and look for which one had the highest recall and the one that I want to work with, and just save it. And then I can use it in my models, and I can just here have the ones that I wanted to use and just focus on them. Great, well done. Now we've done so much already. So the whole logic is made. We've done it in a notebook. We then split it in Python script. So if we go back and we just look at each and every step, we modularize everything. So the step 3 and 4, that's what we did now. We modularize all the steps into Python scripts. We created some test files as well. And then we trained the model and did the hyperparameter tuning and called all those scripts in our run_pipeline.py. And that one runs our whole project. Now it's more of a taking it from here on my computer into making it work from anywhere in the world and even yourselves. So for that, we're going to go through a FastAPI layer, which basically will serve our model into HTTPS, which is serving it to the web, being accessible from anywhere. Then we're going to put the project into a container with Docker. Then we're going to run, test, and push that Docker container from GitHub into Docker Hub or ECR. In our case, we're going to push it to Docker Hub. Docker Hub basically is where you store your Docker containers in the cloud. There is a service for that. It's free. And then we're going to deploy in AWS. Here, the AWS deployment is kind of optional because it will cost a little bit of money. It cost me $10 to run this project for a few days. I will show you later the cost and a few things to be aware of. So if you don't want to go through that step, no need to, but I will still show you how to set up things in there, because the goal here is to really bridge the gap from just a tutorial mindset into like a building real stuff mindset. And I wanted to use real tools that cost money sometimes. The rest, it was all free. But AWS deployment depends on how much you run it, how you optimize it. We're going to keep things very small. If you have the free tier, that's even great. I'm going to show you, if you've never used it, you can have the free tier, and most of these things will be for free anyway. So let's focus on this layer. The number 5 is the FastAPI layer. So if we go here, so FastAPI in our project, FastAPI acts as the serving layer. It turns our machine learning model into an API that can receive data and return predictions. It's necessary because without it, the model will just sit in Python files and no external app, script, or user could interact with it. So it's very important. So there is also this phase of building the UI, but in my case, I've built the UI after I deployed into AWS, so that I have a nice access to the project, as I showed you initially, where we can just input the numbers and we can get the responses, because it's better than calling an API and having the responses in the terminal. Just wanted to show you things that are nice. So if we look at FastAPI, if you go onto their website, you can see a lot about it on their website. But FastAPI is a framework, high performance, easy to learn, fast to code, ready for production. And basically what it does is just a framework for building APIs with Python, basically. And we want to expose our models into the internet, and therefore we'll need to use FastAPI. And believe me that a lot of companies use it, so it's a great skill to have. And the thing is, to start, it's very easy. If you just look on their website, it's literally a matter of just bringing FastAPI, import it, and call app equal FastAPI. And then just by writing this code, you'll already have an endpoint they give you which IP address you just open, and you will see hello world already in there. So it's as easy as that to get going. Obviously there's more complexity, the more complex the project is, but to get started, it's very straightforward. You can find some tutorials on it. Let me know in the comments if there's any of these topics that you want me to dive into by itself. Maybe how to build a FastAPI endpoint in a simple manner, like a very beginner tutorial, or how to turn notebooks into Python scripts, or how to build Docker for data projects, and all these things. Anyway, we'll go to our project, and here inside of SRC, we have the app, and inside the app, we have the main.py. And main.py is where I have my FastAPI and Gradio UI in one place. Now we're not going to talk about Gradio, that's later. So I have like two functions, or two sections, sorry. The first one will be for the FastAPI. We're going to just call the app FastAPI as we saw on the website of FastAPI. and we just give it a title, a description. We want to do things nice. We're just gonna call it .get so that we can get the root of it. This is just to get a health check endpoint for monitoring and load balancing, which we'll be using a load balancer in AWS. This is just to check that the status is okay, basically, that we are able to call that. We're using here Pydantic model. This is just to do an automatic validation, and this is for the documentation as well. So it's basically gonna just go through each and every one of the features that we have and just making sure that they're all okay. Basically, that's all we're doing. And this part is the most important, is we're gonna predict. And what does it mean? We're gonna use our prediction, the machine learning model that we did, to make predictions also in with our FastAPI. So that's the goal, is to be able to do it from our machine and be able to do it from anywhere via this endpoint. The second part is for the Gradio web interface, or the UI. That's something we're gonna look into later. So basically, as you see, we have 3 main parts or 4 main parts. We're gonna just call our app and give it some details. We're gonna do a health check in here by doing this /. It's exactly how you do it. And we're gonna use here Pydantic model for automatic validation. That's an extra step, but it's a very interesting one. And then we're gonna make predictions. So this is all. I mean, I added a lot of comments so that it's clearer for those that are just exploring. But overall, it's not that many lines of code to be able to use FastAPI. 20, 30, 40 lines of code, that's not that much for a project like this. Now that we focus on the FastAPI endpoint, we're gonna talk about containerization, basically using Docker to save all of what we did into a Docker image that can be shared and reproduced from anywhere. So if we go into Docker, just to get an idea, and you can go onto their website and read their documentation. And what is Docker is a faster way to build, share, and run applications. So a lot of people, when they start building anything, whether they're software engineers, data scientists, machine learning engineers, they always get into the point where things work for them, but they don't work for other people. And they say, but it worked on my machine. And this kind of talk is because they don't know how to use Docker. And when you learn how to use Docker, you stop talking like that, because you put everything in a Docker image and you can share it with anyone and it will work from anywhere. So the step here is the Docker image bundles the application code, the MLFlow model artifact, and all the required dependencies. And what happens is that in production, why your model doesn't work on another person's machine is because they don't have the same Python environment, they don't have all the required dependencies, and things keep breaking. But if you package that all into one container and give them that, and they will run the app from within it, then they have the exact same environment that you had on your computer, which means that 99% of the time, if not 100%, it should work for them, because you're giving them the same conditions to make their model thrive and work. So if we go into our project, and now we're gonna go into this Docker file, and you can see here it doesn't have any extension, because that's the way you write it. You literally just create a file, call it Docker file, and it has this nice logo here of a whale in here. And the Docker file is an interesting one and quite a simple one to work with. And you're gonna see it's split into a few key sections in here. So here initially, we're just gonna use one of the Python base images that we have from Docker. We can go onto their website, there are plenty. I'm using this one, 3.11 or -slim. And this one, if you click, it says that it has high vulnerabilities, and these ones are not relevant. I checked them, not relevant for my project. So it's always worth having a look and reading the documentation. But in my case, I'm using this one. Then we're just setting the working directory. It's basically just giving a root directory for this Docker. Then we're gonna copy everything here. The dot here refers to everything that is inside requirements.txt. And requirements.txt is where we had all of the libraries that we used in the project, or that we didn't necessarily all use, but everything that we have in this file. What is it? Yes. And then we're gonna just install pip install upgrade. We wanna have the latest pip, and we're just gonna install all the requirements and just clean basically the path that we have. So here we just install everything and add the curl if we use MLFlow local tracking URI. And then we're going to just copy the entire project into the image. So we first gave it a Python environment. We installed all the libraries that we had as well. And then we're going to copy all the rest of the project. So this is the flow of taking everything that we've made locally. That's exactly what we did. We put and created the Python environment. We put all the libraries and installed them. And then we started building. That's exactly what we're doing here. The next phase here is to copy the models, the machine learning models. And here, why I did that is because I put explicitly some of the models in here, because those are the ones that I wanted to use, one of them anyway. And I did that because usually you don't push these ML runs into GitHub. So you usually put them in a file like .gitignore so that you don't send everything there. So that's one of the things that you do by default. You know, you don't send your API keys, you don't send some of the important information. You can also avoid sending data as well, as I did in here, because sometimes the data is a few gigabytes and you don't want to send a few gigabytes to GitHub. It will bug and you don't want that. So basically this is just to give it the path to get to those models. And here it's even further. It's just for us to give it a path to get the artifacts, to get to the features and the pre-processing, because without the pre-processing, the features will still be categorical instead of numerical, which will end up breaking the pipeline. And this is just me ensuring that things will work well. And this is why a lot of tutorials will not go over this, because it will break many times and you'll have to keep figuring things out step by step. And that's why people don't want to do things live, me included, because some of these things took me some time to figure out and to debug. And doing it live, the video, instead of being an hour and a half, will be forever. So yeah. And then here, we just do this, the serving an app importable about the SRC. So basically here, we just tell it that we get the models from this. This is where we get all the Python files and all the scripts. And this ensures that logs shown in real time. So this is the buffering. So the logs are shown in real time. And this one, this path, lets the import module using from app instead of from src.app. So basically, instead of using here from app directly, it will use src.app. This is just a way for us to make sure that all the relevant data is found in the right folder, subfolder, and directory. Then we're going to expose the FastAPI port to 8000. That's one that you can tweak. In our case, it's 8000. And this one is, we're just going to run the FastAPI using UVcorn, which is this. We just run it. We use Python-m, and we use UVcorn to run the FastAPI. We give it where it lives. So if we look, we have src.app.main, and that's here, this double dot here. App is the root directory of our Docker. And here we're just gonna give it access from anywhere, and the port is 8000. That's what you do, and when you do this, you've already created your Docker file. It might seem a little bit complex because we've added additional steps like this, but in general, you could think of Docker as having these main components. And you see the Python environment. You can see the setting the directory for Docker in this /app, setting all the, copying all the requirements .txt, and this is a dot, that means we bring everything from it. Then we just install it, we copy the entire project, the rest of it, we expose the FastAPI to this port, and then we just run it with UVcorn. This is, for me, just additional to be able to run specific models, because we're not running, for example, just the latest model, because we don't necessarily want to run every latest model, because there is no guarantee that it's the best model. Here, in my case, I've chose something specific, and I wanted it to be used when deploying it to the internet. So this is how we do Dockerfile. Next step will be to use GitHub Actions workflows. So why do we use that? So there's a concept of CI/CD, it's continuous integration, continuous deployment. So now that we have this container that we've created in Docker that has all of our project, we need to do something with it. And in order to do that, we want to use GitHub Actions. And that GitHub Actions will help us test, run, and push that container into Docker Hub. And here, just to have a quick look, in Docker Hub, if you go and sign in, this is our project in here. And you can see it ran 2 hours ago. Last time pulled less than a day ago, etc. So this is where all your containers will live. And our goal with GitHub Action is to push to here. So how we do it is we're gonna create in this .github folder, we're gonna have another subfolder inside of it called workflows. This is like a typical way of doing it. And then we have this file called ci.yml. It's YAML language basically. And we're gonna go in here and we're gonna look into it. And here you see we are gonna build and push to Docker Hub. That's our main goal. So first, when do we push? We push every time we push a change into our main branch on GitHub. So every time, for example, I've made changes, I can come in our terminal, I can just do git status. I see that there is nothing to change. Git does not exist in this case. Git status. Yeah, git status. And then I'm gonna do git add everything and git commit, git push. And when I'm gonna push to my git main branch. Here we have the main branch in here. And when we push to the main branch, whatever we push is gonna trigger our CI pipeline. It's gonna trigger it, and when it triggers it, what's gonna happen, so I can show you more in how it does, it's gonna come into this actions in our repository, and you're gonna see it here running, something like this. And you're gonna see it running, and in real time, you're gonna see what's happening. What's the setup that is happening, and you're gonna see everything one by one. And if anything breaks, it will give you what's the message error, and you need to go back and try and fix it. So let's keep going with the code here. Here we just define when it's gonna work and start. It's when we push anything to GitHub on our main branch. If we have many branches, we don't wanna keep triggering this for other branches, we just want to trigger it for the main branch. Here we just set which OS we're using, the operating system. Here's the checkout code. What matters here to us is this is very important, is having those Docker Hub username and the password, basically. And where do you get it from? You get them from Docker Hub. When you go to Docker Hub, you can go to your account, if I remember. Let's see all together. Yeah, we go here to your account. You will go here to personal access tokens, and here you're gonna generate a new token. So that's how you do it. And when you generate them, you're gonna go into GitHub. You're gonna go to settings. You're gonna go down to secrets and variables, actions, and in here you're gonna create new repository secrets. One, you'll call it Docker Hub token, and you're gonna put the token that you got from Docker Hub. And one, you're gonna call it Docker Hub username, and you're gonna give it your username in Docker Hub, which in my case is Anas Riad 8. That's all. You're gonna put them in there, save them, and then when this script runs, it will be able to, from GitHub secrets, to grab exactly what's in there and give you access to push into Docker Hub, otherwise it will not work. And then after we just see here, build and push to Docker Hub, it's basically just gonna use the content of what we have in Docker file, which is what we saw in here. And the tag here is what you saw in Docker Hub. If we show you just briefly, you can see here that this is the tag, and you saw here latest, and that's exactly, we're just pointing into the right direction. So this is how you build the continuous integration pipeline with GitHub Actions. So everything will be run inside of GitHub Actions in here, and you will see all your runs that you did before. So this is basically every push that I did that triggered this workflow, the GitHub Actions workflow. So now we have the last phase, which is the AWS deployment. So before jumping into it, what I want to do is briefly just show you how you can go and sign up yourself. You just put AWS and you do sign up, and you can sign up to the console. It takes you here, and you can just put in your email. If it's the first time you did, it will give you a free tier, which is great. You're going to use a lot of things for free. If not, and you feel a little bit lost, you just go in here and the resources to create the account, and it will show you how to do things and what you need to add, and choose a plan, and you will need to put in your debit card or credit card, but they don't charge you anything. I think they charge you the first time $1 just so that they have your card, but afterwards it's pay as you go, basically whatever you choose. And just to show you things in a proper way, let me sign in first and I'll show you the costs and everything. So here I am in my root account, and here if I go on the top, so the root account is the one that you use to create this environment. And if I go to billing and cost management, I can see that I've spent $10.82 and it was just on this project. So if I see in here, we can see that the Amazon ECS, so the Elastic Container, is the one that used the most. Then the Elastic Load Balancing, those are the ones that use the most. So these to be careful about, if you don't want to spend any money, obviously you can skip this step. Just watch me doing it or explaining to you on a high level. But if you're willing to get your hands dirty and really learn, because it's valuable to know this stuff, then you can follow what I'm going to show you. So you have a root account. So this is the one that you create initially. And then you create users, and those users, you give them permission to do certain things. So it's advised to not use your root to develop anything. You just create the root to create users, and those users, you give them levels of access needed to perform certain tasks. So for example, you're a startup, you will have 5 employees. Each employee does something different. So based on what they need, you'll give them permission to do those things. You don't want to give a permission to anyone to do everything and end up, just skyrocketing your costs and end up paying thousands of dollars in bills. When I do my tutorials, I try to keep the cost as low as possible, but I worked on this for the past 2-3 weeks, so $10 is not much. Obviously, I didn't spend 3 weeks on the deployment, but still, there are things that I learned myself to not keep running overnight either. So we go to the user that I created. So when you're in AWS, in your root account, it's best to go to IAM, which is the Identity and Access Management. And in there, you're gonna have your users. You can put those users into groups, for example, data people, marketing people, sales people. In this case, I have just myself. And in here, give the level of permissions needed. Like for example, it's just me, I'm giving administrator access and a few access to a few services that I wanna use. ChatGPT is great at helping you figure out what kind of permissions you need and how to work in the console. Just send screenshots and it kind of guides you. It did help me a lot. So this is the first and necessary step. The second step will be to go to VPC, and it's the Virtual Private Cloud, which is necessary to run the ECS, the Elastic Container Service that we're going to use later. And here we can see the VPCs, your VPCs. You will have one by default. I kept it, but you can clearly go and create a VPC, and you can just see what's needed in here. And you will find good tutorials on this topic, but I kept the default one. It's the one that I use myself. And in the VPC, what's good to know is that the ECS will run inside the VPC. We will need at least 2 subnets. Subnet is like 2 distinct IP addresses to reach. And we will need security groups to allow inbound and outbound traffic. One thing also that I need to mention here, obviously AWS, it's such a massive topic that I can't cover everything, but I'll give you as many nuggets as I can. You can see at the top here, I'm in Europe, London. And this one is because I'm using the servers that are closer to me. So if you're in the US, you're going to use something closer to you. If you're in Asia, you're going to use something closer to you, Africa, and so on. I don't even know if there's an African one. No, I don't see it here. Anyway, so you use the one that is closest to you, so that usually you have a better, faster performance and all that kind of stuff. So now that we spoke about the VPC, we're going to go to the ECS, which is the Elastic Container Service. And this one is very important here. First, what we're going to do is that we're going to create a cluster. And you come in here, you create your cluster by just doing create a cluster. And you will give it a name. You will choose the infrastructure. This is very important because we, in this project, worked with Fargate, which is serverless, which means that we only pay for what we use. And every time we make calls, it says here, pay as you go. It says if you have a tiny batch or a big batch, and this one is just to avoid all the overhead of managing your servers. And EC2 instances is basically using servers that AWS provides. and you pay obviously depending on how big those servers are. So I'm not going to create because I already have one here. And in this one, if we see, we can see that it's active. We can see that it has a service. A service is something that we need to create inside of it. We can see the tasks performed and all these things in here. So if you look at the services, here it's very important to have a service. So the service, what it does is that it runs tasks, and those tasks need to be created beforehand. So think of this ECS as 3 steps. You have the cluster, the service, and the task. And the task, you go in here on the left and you define a task. You come in here and you just do a task definition. You can either do it via JSON, or you can do it via just doing it in the console like this, or also you can use the CLI command to write things programmatically. So basically, so I don't go too much into details, I'll show you the one that is already created here, and I've created a few revisions, but the latest one, what it has is that it's using Fargate. It's also, if we look at the JSON here, it's very important. It knows that we're going to bring the image of the Docker from Docker Hub in here because it has the path. It also knows that we're allowing the port 8000 TCP protocol. And here we're just allowing all the logs, AWS logs, everything will be logged for us. And basically just knows that this task execution role, basically just allowing some stuff to run on AWS on our behalf. We're also here declaring the memory, the CPU, and the operating system that we're going to use. So this, you don't have to write it yourself. If when you create, you put every detail in the right order and it creates the JSON for you. But afterwards, if you feel like you want to make some adjustments, you just copy this. You can go and you create a new revision with JSON, and you then go and maybe upgrade the CPU or downgrade, etc. If we go back to the ECS service here, something that is interesting is to look at the update service. And here we have the desired tasks. And if you set it to 1, it will be 1 desired task that is available and running. If you do 0, then ECS won't be charging you for nearly anything. So that's a mistake that I did. Overnight, I just kept it for a few days. So make sure here that if you're not using it, you set it to 0. Or you completely delete it and recreate a new one, but that's the important one. So now, since I have it as 1, we have a service that is running, and we can see that we have an active service. And if we look at this, we can even see that we had 1 task. And that's why we're able to access our UI and be able to do predictions. It's because everything is up and running. So if we go back, now in this, there's another very essential step in here, is to have a load balancer. So if we go to EC2, and EC2 is where we manage servers, even though we're not managing any servers in here, we will look at 3 different things. The first one, we're going to look at security groups. And here we have created this security group in here that I'm going to click on. And this one is very important because it gives us some inbound rules and outbound rules as well. So inbound rules, we're giving access to these port ranges. So 80 and 8000, we're giving them full access, for example, for this one. And this one has access just to the VPC. And the outbound rule, we're giving it access to everything. So it's open to the whole world. And this is very important because when you're going to here go and build the load balancer, you will need to have those security groups in place. So when you look in here, you're going to see that we're internet facing. We have the VPC. We have 2 subnets, as I mentioned earlier. And we're able to run in HTTP 80 in here. So this is very important. And lastly, the target group. In the target group, we're going to see if what we've run is healthy or unhealthy. And this is great for debugging. And you can do all the monitoring and health checks and everything in each and every step of it, so that you can see if things are working properly or you have to debug something. So when this is all in place, you usually just, you run and you push your model and you go to ECS, back again, we can go to ECS. And if you have made any changes and you want to push them again, you just go to the cluster, you go to the service, and in here you just force a new deployment and it will force the deployment. And then what will happen is that I'll show you briefly the Gradio UI. If we go back to src main.py, so as I told you, we had it split into 2, the FastAPI, and the second phase was Gradio here. So Gradio is a Python library to create interfaces, and here you see all the interface, every basically area that we had, and the data that goes into it, and basically just the options that you have, just drop downs. I don't want to bore you too much with this. You can look into the code and play around with it. And then what happens is when you deploy all this and you get the URL from the ALB. So I'll show you when you are in EC2. This is the URL that you get basically. You go to load balancer, you click in here, and you get this this URL here, and that's the one exactly that we're using here. So that one is right in. If I remove the .ui, because you have to include it, it just gives you a status OK. But in our code, we specified that it has to be /UI, and now it's taking you here. And when you input the numbers and the values, then you're gonna get the prediction based on what you did. So now I'm honestly just put in random numbers. So I don't know what's gonna be predicted there. But this is how, in reality, when new streams of data is coming, we're gonna know that whether it's the person is likely to churn or the person is likely to stay, basically. So we're gonna submit, and we're gonna see that this person is likely to churn based on the information that we've provided in there. So here, I didn't look too much into showing you exactly the architecture of AWS, but basically we use an application load balancer to handle incoming requests. That's what I showed you how to do. We used ECS Fargate as a serverless container running the Docker image from Docker Hub, basically by creating task definition, a cluster, and a service. And CloudWatch, we can use it for monitoring. I didn't show you this, but you can use that to keep track of what's going on and monitor the health, the logs, and the performance metrics. So everything that we saw in here is how to go from a basic just notebook style, let's optimize the accuracy style projects into a real world production ready, going from A to Z, and with all the steps that we spoke about, from setting the environment, from doing the EDA, from modularizing all into Python scripts, to using FastAPI to get the model to be used in the web via HTTPS endpoints, to build a Docker container so that we can package the whole project to be reusable from anywhere, to use GitHub Actions to be able to test, run, and deploy the whole projects in the cloud, and in the end also adding a UI so that it's nice and pleasant to play around with our model. So you've literally learned how to do an end-to-end machine learning project. This is a churn classification problem, but you've learned so many things that are reproducible and reusable in so many different projects. And I hope that you found this interesting. Please leave in the comment section if there are anything that you want me to expand on in other videos, maybe just specific topics they want me to talk about, Docker or GitHub Actions and how you can deal with them, or maybe a specific video on AWS, which will kind of force me to also try and explain it to you and learn more about each and everything. I will be doing a series of projects like this, where I go end-to-end in projects that can grow in complexity. I will try and keep it as real as possible so that you can learn this and use it in your next career project, or in your freelancing, or in your job. And I hope that you really benefited from this. If you did, please remember to like this video, share it with your friends, comment if you want me to do anything similar, or there is something that wasn't that good, or something that you want me to dive more into. I tried to keep it as compact as I could. 1 hour and 40 minutes nearly, that's quite a lot, or 1 hour and 20-30 minutes is quite a lot, but I tried my best to give you something that is quite complex, but a big overview of it, and you have access to the code to play around and build these things yourself. So if you find any problems, just leave them in the comments and I'll try and help you on my end. I hope you enjoyed it, and I'll see you on the next one.